All right. Good afternoon, everyone. So we are in week what? Week number? Who remember? Week number 6. Excellent. Week number 6, first class. And today, inshallah, we'll try to start a new chapter, but after finishing the previous chapter. What did we do last time? We talked about what? Small signal model. What other? Yeah, we talked about the models in which region? Forward, yes. We discussed the forward models, forward bias models of the diode. If the diode is in the forward, we have typically about 3 models. We have the exponential model. We have the ideal model, and we have the CVD. No, CVD. No. Let me make sure that you are not confused. A small signal model is only for AC analysis. Okay, small signal analysis of the diode. Okay, it's a model specifically for small signal analysis. If we are doing DC signal analysis, we have 3 models: exponential, CVD, and ideal.
But all of them are forward bias, yeah?
All are forward. Now we are talking only about forward these. Yeah, good question. Do you understand?
Yes.
So these 3 models are only for DC analysis, and I have written that. Remember that?
Yes.
I've shown you that. So that's for the forward bias. Now, if we do the AC analysis later on, you see in the MOSFET, BJT and stuff, even with the simple circuit, when we do AC analysis, we can use in that case the small signal model. Do you understand? Okay? Good? Very good. Good. So that's for forward. Now for reverse. Do you have a model? Yes, we do, and today, inshallah, we study that. Okay? But before studying that, let me show you something new. This is a new diode that is coming for the first time to you. It's called Zener diode. And Zener diode is a special diode. First, let me repeat. It's normal diode. At the beginning, for forward bias, it's the same as any other diode. For forward bias, Okay, let me write. Forward bias, normal. Now, it's like any other diode. Now, when it is in the reverse bias, it has special thing. In the reverse bias, in the real diode, what are the domains or the zones or areas of the diode that works in the reverse bias? Remember in the real diode?
Yes.
It has 2 domains, yes or no, in the reverse?
Forward.
No. We are in the reverse. Wake up, just a second. So it's not forward. In the reverse, there are 2. There is one zone that is normal, reverse, and there's another zone, breakdown. Very good, very good. So these are the 2 zones or 2 areas of the real diode, not the ideal diode. The reverse diode is simple. The model of reverse diode is open circuit. The current is very small. You can assume that it's open circuit. Okay? Good?
Yes.
Now breakdown. We need the model for that. We are going to show it next. And that's the model that we need to discuss. You understand? For reverse zone alone, it's open circuit. There's nothing we can do about that. Current is 0, 0. Khalas. Now for the breakdown, we have a model. For the breakdown, we have also a special diode. The diode that works the best in the breakdown is the Zener diode. Why? Because it works the best. I will show you how it works better than any other diode. But it works the best in the breakdown. That's why we call it a Zener diode. Because the breakdown, when does it start the breakdown?
Less than.
Raise. Leno, some students, they speak and the others, they are watching. So please raise your hand to give the others chance. Someone somewhere here? Yes? Is what?
Less than 5.
Not necessarily 5. Why 5?
Because it's written.
Not necessarily. Again, this course is not history and geography. It's not memory, whether you memorize the number. It's not about that. But that's great. It's good to try. is less than, is true, but less than what? Zener knee voltage, VZK, remember?
Yes.
This voltage, VZK.
Okay.
We said that if the reverse bias of the diode is higher than the Zener knee voltage, we said the Zener knee voltage, if it's higher than that, then boom, the current will increase too much in the reverse bias, and we call that area the breakdown. Okay?
Yes.
The breakdown zone. Okay? Now, that breakdown, what does it break really? It breaks the fact and no, a diode is not open circuit anymore. Now it's conducting. And will conduct lots of current. Let's go there. Very good. See, now I'm changing the effects transition. Magic. So now, after the VZK, boom, the current increased so much. Yes, it's negative here, because the current now is going from the cathode to the anode. So opposite to the convention. صح ولا لا? If it's opposite to the convention, the istilah, then in that case it's negative. صح ولا لا?
Yes.
Do you understand? So the current is huge. It's huge. Going very fast. See what I'm saying? So this is the area that we call it the breakdown. Remember, for those who revised. Huh?
Yes.
Good? After VZK. Or after minus VZK, لأنه VZK usually is reported as negative value, and we are in the negative value of the voltages. Understand? We are in the reverse. Okay? Any question? Clear?
Yes.
So after VZK or minus VZK, now the current will increase very, very fast. But the voltage again does not change too much. So it's almost vertical. Zener diode is the perfect vertical line here. Why? I will explain that in a second. So because the voltage does not change too much, so I can replace my diode in this case by what? Why resistor?
By battery.
Very good. Why by battery?
Because it's
constant.
going
Big-
to act like battery whenever.
Because the voltage does not change much, صح ولا لا?
Yes.
It does not change by much. It's almost constant, same like a CVD model, if you remember.
Yeah.
صح ولا لا? But now it's in the negative. And that's why we have this battery like that. Look, the high voltage is in the negative side. صح ولا لا? Do you understand? And the negative side of the battery is on the positive side. That's why this voltage is negative. Do you understand? Do you understand? Because the battery now is supposed to be here. It's supposed this one higher than this. But the convention is that this plus and this is minus. But however, the battery is actually, this is higher than this. Why? Because we are reverse biasing the diode here. Do you understand?
Yeah.
Do you understand? Got it? Excellent. So this is the part number one in the breakdown model of our diode. Okay, what's the value of VZ0? The battery of this battery is VZ0 or VZ0. That value is what? How do we find this value? If I give you a graph, always take note and try to remember these things, because again, the video is not necessarily a done deal. It's not going to be really available for a done deal. Only those who work hard. So remember this very, very carefully. Now, if we draw a line here on this curve like this, one line, it will cross the axis of the voltage on a value that we call it VZ0 or minus VZ0. And that's the value. Why it cross there? Because at that point, the current is equal to what? Is equal to 0. That means we don't have any resistance here. Okay? Or if there's a resistance, it will not do anything. So basically, when the current is equal to 0, the voltage across the Zener diode or the diode in the breakdown will be only this one. Now, the voltage across the diode will be only this one. Okay, that's called VZ0. This is how we get it. Very good. So now we understood where this comes from. Good? Excellent. Very good. Now, let's continue our modeling. This is called modeling. This is also a task of an engineer, usually of scientists as well, to model things to understand how they work and to use them in the analysis. Okay, great. So, now, the line here is not vertical. It has a slope, yes or no?
Yes.
It has a slope, huh? See this alpha? There's a slope. It's almost like a line. It has a slope, okay? Alpha is the angle. The slope is not alpha, it is a tangent of alpha. صح ولا لا? Make sense? Tangent of alpha. Yes or no? Very good. Now, what's this slope? So this I call it slope, yes or no? How to find this slope?
1 over R.
Why 1 over R?
Because you have IV.
Because what?
IV.
شو هاي؟
I in the Y.
Well, is it history, geography?
No.
Teach me. It's not about memorization. How do you find it? Hey, how do you find it?
Because ohms no.
So how do you find? How do you find that the slope of this line, which is tangent of this angle, is 1 over R?
The difference in I divided by difference of
Excellent, excellent. That's the one. So it's the variation of y divided by variation of x. صح ولا لا? That's the way. Do we need to memorize this? Hey, no, of course no. Because this is a line, so that means, yes, it's a line, so لهنا is constant, صح ولا لا? And the current over voltage for constant, in this case we are using Ohm's law, it will be what?
1 over R.
Very good. So Mr. Ohm, which we trust, apparently I hope that we trust, some people they don't still, huh? But please trust Mr. Ohm. So it's 1 over R, we call it Z. Why? Because we are in the zener zone. Break down, we can call it zener zone, that's fine, okay? فهمنا ولا لا? Good? Clear that? Clear? Very good. Alright, so why we need the slope? Because the following. Now, if I want to find the voltage on this curve, what do I do? So if I take this as a line that starts at VZ naught, okay, it starts here. So what's the value here of this point particularly? So it will be what? It will be this VZ naught plus, it's very hard to explain it here, 1 over the slope times the current, which is in this case, this distance, okay? So it's very hard to explain in here actually. So in this case, so now, so any point in here, it will have what? Let's take one particular point, which is this one. Let's take this point. This point has x and y, yes or no?
Yes.
And both of them, they are negative. صح ولا لا? Excellent. صح. Now, if I want to find the VZ of this point, we call it, by the way, test point or any point, okay? We call it test point. So, the voltage of this point, which is Vz, is going to be equal to this voltage, Vz naught, plus this distance. And this distance is equal to what? Is equal, what's that? Is equal to delta V, and that delta V, very good. So this distance, we call it delta V, very good. So that delta V is equal to what?
VZ minus VZ naught.
No. This delta V here. It's VZ minus VZ naught. صح? That's okay. That's good. But how do I calculate it? Remember that delta V over delta I is equal to what with respect to tangent? It's 1 over tangent. صح ولا لا?
Yes.
Equal to R.
دقيق. 1 over tangent is equal to what? As you said? RZ. Yes or no?
Yes.
So delta V is equal to what?
RZ times I.
So delta V is equal to delta I.
Yes.
صح ولا لا? Delta I times
Times RZ.
RZ. Very good. But delta I really, the delta I, the difference between this point and this point, really this point is nothing. صح ولا لا? We can assume that this value is almost 0. Yes or no?
Yeah.
صح ولا لا? Make sense? So delta I is nothing but I. Is the current, yes or no? Because this value here, delta I means I from here minus I from the start. Yes or no? Which is IS. صح ولا لا?
Yes.
IS, you can neglect it. It's very small. صح ولا لا? It's open circuit. You understand? This value here, this current. It's almost zero. صح ولا لا?
Yes.
You understand? So we can say this delta I is nothing but I here. صح ولا لا? فإذا delta V is equal to I times RZ. So in this case, I can write the current, the voltage across the diode in the breakdown as VZ naught plus RZ IZ. When? For only we are in the breakdown, then I have to use the absolute value. Huh? It's absolute value. Because IZ is negative and IZK. Or you can say that we are taking the absolute values in here, okay? Just I do that so that you know that we are talking about absolute values. Because sometimes we say IZ is positive, like in this case, but sometimes we say it's negative. But here we are talking about absolute value. So when IZ is above IZK, yani we are in the, where? In the breakdown, yani we are, this is IZK. Yani the current is going here, and the voltage is above VZK. Yani we are in the breakdown. That's what it means here. Okay? Then IZ is above IZK, and VZ is above VZK. We are in the breakdown region. Good? So, in summary, we say that the diode in the breakdown is like a battery in series with the resistor RZ. Do you understand? Where the battery, the high voltage of the battery is on the cathode, and the low voltage of the battery is on the anode. Because it's reverse biased. Because breakdown happens in the reverse bias. Doesn't happen in the forward. If it was in the forward, here it should be opposite. صح ولا لا?
Yes.
Like in the CVDM model. In the CVD model, this has to be with this one. Do you understand? So this point is this point, and this point is this point. So this is, in the forward should be in the cathode, in the anode, not in the cathode.
Yes.
Okay? Something like that. Do you have any question?
Sir, if IZ equal IZK, it will be breakdown?
Very good. It will be the start of the breakdown. It will be the start of the breakdown. That means you can apply this equation. Or you can say that we are almost in the reverse. You'll be fine. It should be, because it's at the boundary, yes or no? So it's with this and with this. Not لا إلى هؤلاء ولا إلى هؤلاء. No, إلى هؤلاء وإلى هؤلاء. For both. At that particular point. At ZK. No?
And I equal minus IS?
I is equal to, yes, you can say that. Yeah, at the knee voltage, at here. You can assume that. Yes, you can assume that. It's not exact, it's not accurate, because it's actually after that a little, okay? But you can take that approximation and it'll be fine. Linear saturation current is quite small, so you can ignore that. No? And even IZK is not that far from that value. Okay, now back to Zener diode. What's particular? What is special about Zener diode? Zener diode is special in this. Is that the resistance of Zener diode in the breakdown is extremely small. Extremely small. Very, very small, so that the diode in the breakdown is like what? Is only like a battery only. Do you understand? And that's why it's nice. Because we said that the diode in the forward bias, it can be used as what? As voltage regulator, remember?
Yes.
يعني it's like a battery. تعطينا battery, صح ولا لا? That is very nice feature, صح ولا لا?
Yes.
Extremely nice. Now we can use also Zener diode as a voltage regulator. Because here it's almost like a battery, true or no? Very good. صح ولا لا? Makes sense? But the one that does not have the voltage change, the voltage will not change if the resistor is
Small.
very small. And that's why Zener diode is good. Do you understand? But other diodes also they have the breakdown, but the resistance is much bigger than the Zener diode. Do you understand? That's the only special thing about Zener diode. In the forward, they are all the same, but in the reverse, the Zener diode, they are the best. They are good batteries. That's one thing. And the other thing is that the Zener VZ naught is much bigger than 0.7, like in CVD, remember?
Yeah.
This one is in 5 volt and more. Do you understand? So I can have a very good voltage regulator. Yes or no? With higher voltage, صح ولا لا? It's not with the 1.7, 2.1 volt. Do you understand? Do you understand? So that's the beauty of Zener diode. Good? We are going to go a little bit fast now, because now we understand everything. Now we have a problem to solve. We are not going to solve this all together, but we'll try to start something, and then I'll let you finish the rest. It's also solved in the textbook. Who has the textbook? Who has the textbook? Who does not have the textbook? Let's see. So those who does not have, now who have it, and the rest, they have and they don't have, يعني?
We have slide.
What's that?
Slide.
They have slide.
Yeah.
But the problem is not in the slide.
No?
The problem.
No, there is.
But the solution is not there.
Yeah. We will see it.
Okay, good. She's preparing the answer. Very good. Nice try. Nice try. Please try to bring your textbook. حتى ولو cut it on chapters. Bring the chapter that you are studying. صح ولا لا? If you have to, you have to. فهمنا? Cut it. Some people they repeat, take only chapter that you need. فهمنا? It's very important. Why? To compare our results to their results and our way of solving with their way of solving. Okay? Do you understand? Clear? Good. So let's see. So now I have hidden this one for a reason. See? So, Zener diode, and this is the symbol, is like any regular diode. صح؟ دقيقة بس. This is regular diode, yes or no? The only thing that we do, we have this and this. And that becomes a Zener diode. Special only in the breakdown.
But Doctor, here we have positive terminal, right?
Yeah, same thing, same convention. This is should be the positive, this is the negative. But if you use it in the breakdown, of course, this has to be bigger than this. But this is the reference, the choice. When you measure like this. High, low, common, and the voltage. فهمنا ولا لا? Good. So the Zener diode here it gives us is called 6.8 voltage Zener diode. What's 6.8, sir? What does it mean? It means it was measured at 6.8 volt, and the manufacturer, the data sheet of this, the manufacturer show us that he measured the voltage VZ of 6.8 in the reverse and gives us a current of 5 milliamp. يعني in reality it's actually minus. فهمنا ولا لا? But when we multiply everything with plus, it's like we are turning the thing like that, and we are in good shape. فهمنا ولا لا? Anyways, so the manufacturer measured this Zener diode and told us that, listen, for the breakdown voltage of 6.8, I have a breakdown current of 5 milliamps. صح? And then what happens? And he tells us, oh, listen, I give you even RZ. اللي هي Zener resistance, 20 ohms. 20 ohm, is it big or low?
No.
It's a joke. It's nothing. If you assume 0, it's fine. فهمنا ولا لا? It's extremely low. Now IZK, see IZK? 0.2 milliamp. It's very small, but compared to IS, it's bigger a little bit. صح ولا لا? So scale is, small. فهمنا ولا لا? So IZK, that's when the start of the breakdown. Okay, good. V plus is the supply voltage, is 10 volt plus or minus 1.
Sir, what's
Yes.
the difference between IZ and IZK?
IZK is the Zener near current. احنا قلنا البريك داون يبدا على VZK IZK. النقطة هذه نسموها the start of the breakdown. Let's go back. Good question. It's fine. This is the start of the breakdown. This point has coordinates. صح ولا لا? X, Y. صح ولا لا? الX نسميوها VZK والY IZK. coordinate. إحداثيات. دقيقة. نرجع للIZ. IZ that he is mentioning where here is the test point. Is one point where easy. دقيقة. Is this point. One of the points in the breakdown. He gave us only one. He said, now listen, I test this Zener diode at this particular point. يعني at this current, at this voltage. Boom. I know sure that the diode is working at this point. Do you understand? So IZ can be anywhere here. But IZK is the start. Boom.
Yeah, Doctor, it's constant.
Oh yeah, it's given. That's for sure, it's constant. Yeah, it doesn't change. But IZ or VZ can be anywhere in this line. Do you understand? Can be anywhere. You understand? That's a good question. See? Did I blame you when you ask?
No.
Why do others they don't ask? It's good to ask. When you ask, you know things. صح ولا لا؟ Yeah. There's مثل يقول اسأل حتى يسموك مجنون. خليهم يسموه مجنون. أنا نتعلم وخليهم هم يسموه مجنون. Do you understand? Who cares? At the end of the day, you get 100, and the rest, they enjoy their CUF. Well, that's fine. I'm crazy, you are smart, enjoy your F. I enjoy my A. How does that sound? Like good, huh? I like that. And they take, hamburger, and they enjoy my life. And the rest are crying like crazy. Anyways, good. Anyway, good to ask. Always ask. Don't stop from asking, okay? I'm here to help you. All right, go. So the question here, ladies, is find V0 with no load. So this is our circuit. He said V0, يعني V output heavy, without RL. We take this, so there is no current coming out. صح. How to find V0, this voltage?
As RL.
What's that? Suggest anything. Just tell me what you think and we'll see.
The same as RL because they are like in diodes.
دقيقة. لا. احنا we are looking for this voltage. For this voltage at this point. That's the point. The current, yes, is the same. But the question is not about the current, it's about this voltage.
Voltage divider rule.
Where the voltage? صح. Okay.
First
Sure.
we will take
Fine. But
high.
here. But how do we study this circuit now?
So VO is not equal to V in the diode?
1 second.
VO is not equal to V in the diode?
Yeah, the V output هو the same as the diode voltage, yeah, and then
The voltage of the diode.
hey, voltage of the diode. This output is the voltage of the diode. Hey, yes. Keep going.
Okay, and the question V, it's not for
No. The question is to find V out. Hide the question. Do you understand the question? We want this voltage. يعني cross the diode. صح ولا لا? That's what we're looking. Yes. 1 second.
First I will find the current.
How do you find the current?
V10 minus 6.8.
Who told you that this is 6.8? If you put this 6.8, خلاص, V out is 6.8. But who told you that?
Because the ground is here.
Was that the ground is where? So what if the ground is here? Doesn't, yeah, it's not necessarily, yeah.
Minus 6.2.
No, here, do you understand what means 6.8 volt اللي هنا? It's where we have tested the diode. It's not where the diode now is working. We don't know. This is the test point that, what's your good name? Aisha. That's the point where she asked what means IZ. This is just a test point of the diode. The manufacturer tell us, listen, if you apply 6.8 volt across this diode in the reverse, you get a current of 5 milliamp. That's it. But now we put the diode in this circuit. Now we don't know what's the voltage there. How do we know? Is it 6.8? Not necessarily. It's not necessarily. Do you understand? Make sense?
Yes.
How do we study now? This circuit.
First we
Yes.
Replace the diode by battery and resistor.
Very good. So the first thing, she's smart because she saw this, but that's good, yeah? So the first thing is to replace the diode with a model. What we were doing in the morning since 40 minutes. We were talking about the model. أنا بحيت أصلا صح ولا لا؟ نتكلم عن الموديل. We need to use the model, yes or no? We are in the breakdown. Why? Because the diode is reverse biased by 10 volt. And we know that, IZ, VZ اللي هنا 6.8 وإحنا عندنا لهنا 10. So we are guaranteed we are in the breakdown, yes or no? We are for sure in the breakdown. There's no question, yes or no? Got it? So now we can replace this by the model. Excellent. Once we replace by the model, now we can study. Very good. So let's study. So now I can write the equation V out like this. V out is equal to what? What's the model said? From the circuit, V out is equal to what? Somebody? Yes? VZ not? Plus?
plus IZ times R.
Exactly. times R IZ. صح ولا لا؟ Very good. So what we are looking for? We are looking for this one. صح ولا لا?
Yes.
All right. So this we don't know. Do we know VZ naught? Do we know VZ naught? Do we know VZ naught?
No.
No, we don't know. So بالأحمر we don't know. Do we know RZ?
Yes.
Very good. So we know RZ. Boom.
Why
Do you know IZ?
Yes.
Yes.
5
No, but just a second. This IZ, I cannot really call it IZ actually. Because I here in this is any I actually. We cannot write IZ by the way. It's I only. It's this current. Well, you can call it IZ, that's fine. But it's not necessarily this IZ. Because this IZ happens at this VZ. Do you understand?
Okay, we would call it IZ naught.
Very good. Very good. 1 second. IZ not. We cannot say that. Anyway, this IZ is not the same as that IZ. I will write this. Not this one. فهمنا ولا لا? Do you understand? When you see the video, if you're lucky, this will be there. صح ولا لا? Now, we don't know this, we don't know this, and we don't know this. Do we know this? We don't know. صح ولا لا? Do you know this current? Do you have any idea about this current? Which is actually this current, I.
Yes.
That's what I mean, I. Let's continue. Let's delete this, so that we are not. So, okay, which is that current is there. Now we don't know this, so we have 3 unknowns.
We can find
Sir,
this.
I equal IZ.
Just a second, yeah.
I equal IZ.
I equal IZ. صحيح. I is equal to IZ. That's fine.
Well,
But hold on, continue.
I
لأن هذه
equal
أصلاً
IZ plus.
لا الاي ار
No, no. I is equal to IZ when V out is equal to VZ. Got it? Let's repeat. Let me repeat. The manufacturer said that if the voltage across the diode here is equal to VZ, then the current that will pass by the diode will be equal to IZ. Very good. That's what I say. I'll tell him thank you very much. And they come here and they write. So I write VZ اللي هي هذه. صح ولا لا? Is equal to VZ0 that I don't know. Yes or no?
Yes.
Plus RZ which I know. Times what? IZ that I do know. Now this is going to be this, and this is going to be that. Do you understand? So we say that if the diode is working at this voltage, the current must be this current, and I can replace. Now, in this equation, what we don't know,
VZ
now we can get VZ naught. You see? Do you understand? So now, from here I can write VZ naught is equal to this VZ minus RZ IZ. صح ولا لا? Good?
Yes.
But the story is not finished. So we just found this voltage. صح ولا لا?
Yes.
Which is constant. Understand? Good. Very good. Did we finish? No, we
Need to
didn't.
find I.
We can find I by V minus VZ naught over R.
Not VZ naught. It's not going to be VZ naught. It's going to be V out. So in this case, so let's see. If we write that equation, what you meant, I will correct it for you.
But Dr.
It will be V plus. I will write it here. It's actually the current here. It will be V plus, which is this voltage,
Yeah.
minus this voltage is V out. صح ولا لا?
Yeah.
Divided by R is going to be equal to I. Yes or no?
Yes.
It's the same current that is going by this one. So in here in this equation, what do we don't know? What we know, what do we don't know? We don't know I. Yes or no? Boom. We know V plus. Boom.
10.
V out, we don't know. R, we know. Yes or no?
Yes.
It's given, صح ولا لا? Somewhere? It should be given. 0.5 kilo ohm. And we have this equation. And we have now, we go back to the original equation. V out, we don't know. Yes or no? VZ naught, now we know it, so we cannot say. So now we can say it's okay. صح ولا لا?
Doctor, what about small r?
Small RZ? عندنا RZ.
Can we write
Sure, continue.
I don't know.
لأنه we don't know this voltage.
يعني الحين يوم بيمر الكرنت الريزستور ما بياخذ.
بياخذ voltage. لأنه there will be a voltage line. But we don't know what's the current here. We don't know what's the voltage here.
So sir, why did you not consider it? Like
What?
R plus R small.
R plus R. No. V plus.
صح صح.
Wait a second. I'm wrong. Yeah. Wait. No, actually you are. No, wait a second. In Ohm's law, I'm writing the Ohm's law cross this. So it's this minus this. Now, okay, very good. V out is here. صح ولا لا?
Yes.
Okay. Now, if I write here this equation is correct. V plus minus V out divided by R will give me this current. صح ولا لا?
Yes.
Do you understand? That current is the same like this voltage minus this voltage divided by this and this. But why do I complicate it? It's very simple here. Why do I complicate it? Because here I'm looking just for, not for this voltage. We are looking for the whole voltage here. صح ولا لا?
Yes.
So this equation, give me an equation where I have I and V out as unknown, the rest are known. And then I have another equation also that relates V out with I. Yes or no? This is unknown, this is unknown, this is known. So two equations, two unknowns. Can we solve that?
Yes.
Good luck with that. خلاص? So in this case we will know the current and we will know V out. Yes or no?
Yes.
Cool? You will practice at home. We are not going to do that here. You understand? Good? Very good. Just we apply Ohm's law. That's it. That is absolutely nothing. We applied it here. We applied it there. We are, everything is happy. Okay? We solved the first one. Then the rest I leave you to try to solve it at home. It's already solved in the textbook. It's straightforward. I wanted just to show you the most important part where you can start thinking and solving. The rest is enjoy your life. Do you understand? Use mathematics, because without math, you will not be able to solve anything. Do you understand? When we say variation, we are using delta. Do you understand? When you use delta, you know the variation when you use the variation equation. Do you understand? In any case, have a look at that. Continue the rest. I'm sure you will enjoy it. It's also solved in the textbook. And we need to move forward because we don't have time for that. You have the TA and you will enjoy this. Now let's move on with the course. Now today, inshallah, we get back to the rectifiers. What do we do with the rectifiers? What do they do?
Convert AC to DC.
Not exactly. We use them in the conversion. They are just part of it.
Make the current move only in one
Only
direction.
in one direction. It rectifies. يطول. Rectifies the direction of the current instead of going back and forth. Only one way. Means that the output will have only one sign, either positive or negative. Usually we take it the positive. Okay? Do you understand? So in this case, the AC that has plus or minus, after the rectifier will have only plus. And that's the purpose of that. Now, when you use to charge your mobile, some of you, they have used it in class, and now they stop that because the channel will fly out. When you use the mobile to charge the mobile, if you take the charger and break it down, don't break your charger. Look for anything and break it. The first thing that you find after the transformer, so this is your voltage source. This is the plug. Where is that? Is this? That's what's in here. After that, there will be a rectifier. The first thing. Do you understand?
Idea.
What's that?
Ideal diode.
Well, we're using real diode. We'll talk about the circuits for the rectifier. We started one example. We'll discuss today the rest of the examples. Do you understand? Very quickly. After the rectifier, we send that voltage to another circuit. We call it the filter. So after the rectifier, the input will be AC. The output will be just the positive voltage, but up and down, up and down, up and down. The filter will say no up and down, up and down. We filter all these downs. We keep only the uppers. Okay? Then we send this to another circuit. We call it voltage regulator. We have seen that. So the voltage regulator will fix this voltage at a certain constant voltage. And then give it to your battery. to your mobile battery. Do you understand? That's what you are using all the time. See, how useful is this course? Interesting. This is everywhere. You find these circuits everywhere, okay? We're not going to discuss about this. You can also read this, so I said already enough. Now, the first type of rectifiers, we call them half-wave rectifier. Half-wave rectifiers, what do? We studied already this one. What do? They take just the positive cycle of the input voltage and reject the negative cycle of the input voltage. Means when the input voltage is negative, this diode will be what? Open circuit. We have to hope that this diode is not going to be in the breakdown. خلاص? This has to be not in the breakdown, in the reverse. We come back to that. So in that case, it's open, no current. So the voltage here at the output is going to be 0. Yes or no? And then when the voltage is above VD again, which is 0.7, the current will pass and we are in business. And so on. See, the input has up and down, but the output has only up and sleep. Up and sleep. See? Up and sleep. So it takes half of the wave, but the other half, sleeping. Nothing. That's why we call it half-wave rectifier. Take only one wave, the other half, bye-bye. Salamat salmak, okay? Good. So before we leave this, we have two graphs. This graph, we call it the transfer curve characteristic. Why we call it transfer curve? Because the input is on the axis, x-axis. Input is here. And the output is in the y. So y is out and x is in. You understand? The input voltage. No.
Yes.
Now, when the input voltage is negative or is less than VD, the output is equal to what?
0.
When it is above, the input voltage and the output voltage are what? They are the same. They differ only with VD here. You understand? So if you write down here when the diode is constant, so the voltage here, which is the S, is equal to this voltage plus this voltage. Now in VD, this is positive voltage, yes or no?
Yes.
It's constant, yes or no? 0.7 is a battery, yes or no?
Yes.
Yes, good. So here is the high, this is low. So it's like this voltage, yes or no? So V out is equal to Vs plus 0.7 volt, yes or no? Do you understand? Now the slope, how do we find the slope is equal to 1? Again, thank God for mathematics. We do the variation here. It's going to be the variation of the whole thing here. When you do that for 0.7, bye-bye, it's going to what? 0, yes or no?
Yeah.
Because there's no variation. So delta V out, delta what? This is the slope is delta V out over delta V in, yes or no?
Yes.
So delta V out divided by delta Vs is equal to what? Is equal to. And that's the slope. 1. Got it? But only when Vs is above Vd, yes or no? When we have business, when we have current. Okay? When we have no business, no current, so there's no equation like this. Good. So this is the first one. We understood this. We are not going to repeat that. Now, the maximum voltage now, back to this circuit. What's the maximum voltage in the reverse bias? When the diode is the reverse bias, what's the maximum voltage across it? It will be Vs, yes or no? And when this is the reverse bias, that means this voltage is above this. What's the maximum voltage that we can reach with Vs? It's this one, yes or no?
Yeah.
So, that maximum voltage, we call it the PIV, the peak inverse voltage. It means the peak, the maximum voltage of this diode in the reverse bias. And it's going to be equal to Vs in this case. We'll come back to that here. The PIV voltage is a very important value that we need to extract for the diode when it is in the reverse bias in a circuit. The diode, if it's in the circuit, the voltage across it will change over time. We have to find the maximum value of the voltage across that diode. In the reverse bias, why? Because of the following. When we find the maximum reverse voltage of that diode, we need to multiply it by 1.5 to find the Zener knee voltage of the diode that we need to purchase. Meaning, let's say I want to build this rectifier in the lab. I want to sell it, make business, make money. So what do? I take this simple circuit and I found, wallahi, this the PIV, the peak inverse voltage or the peak reverse voltage of this diode is Vs. That's the maximum reverse voltage we can have here. How much is it? Let's say Vs in this case, let's say 6 volts, so that we don't repeat 5 volts. Okay? Good. Now, when I go and purchase the diode, which diode I have to buy to make this rectifier not going in the breakdown? Because we need the diode in the reverse bias to stay in the reverse, not to reach the breakdown.
Yes.
To be in the safe side, I go to the electronic shop and I tell him, listen, I need a diode that has the VZK voltage equal to 1.5 my PIV, that is 6. So 1.5 times 6 is 9. Give me a Zener diode, a diode that has VZK is equal to 9. So in this case, I'm safe. So the diode in my circuit can have like 5 voltage in the reverse bias, but because the VZK, it means when the start of it starts at 9, yes or no?
Yes.
So I will not reach the breakdown. Do you understand? You got the point? So I will be in the safe side. My diode will not be in the breakdown. Why? Because the rectifier should not have any current in the breakdown. Should not have a breakdown. Should not have any current in the reverse. Should be only in the reverse. Never be in the breakdown. Never. If I reach the breakdown in my rectifier, I have no rectifier. I will tell you, go study something else. Yes?
When do we use the peak inverse voltage?
We use it when we build the circuit. Yani, if I want to make this circuit, I want to build it, I need to know what is the maximum reverse voltage in this circuit across this diode, of this rectifier, across this diode. If I know the value, I will go and purchase the diode that has the VZK value, that is equal 1.5 times this voltage that I found. Why? To make sure that this diode will never reach the breakdown. Do you understand? It can be in the reverse, fine, but it will not reach the breakdown. Why? Because the maximum value is this value across it, yes or no? Now I'm giving 1.5, I'm giving 50% extra room for my diode, just in case, who knows, to stay away from the breakdown. Do you get it?
Yes.
Got it? Clear? Very simple, very simple. يعني شوية سهل. Okay, good. I'm not gonna talk about that one too much because it's and same like this one. It's not of a very big deal. Now we get to the second type. The second type of rectifiers are the full wave rectifiers. The full wave rectifiers, comparing to the half wave rectifiers, they take both the positive side of the input and also the negative side of the input. Then it doesn't sleep anymore. It works here and there. So it's good, yes or no? So I'm collecting more voltage. Most of the time. Excellent. All right, that's it. So we have two types of full wave rectifier. We have this we call the center taped full wave rectifier, and we have the bridge rectifier. And that's it for today. But we are not leaving now. For the transfer curve of the full wave rectifier, typically is this curve. So basically the output voltage is not equal to 0 in the when the input voltage is negative. No, it has value. Do you understand? It has value. But still the value of the output is positive. The slope is negative with respect to the input. Why? Because the input is negative. But the output voltage is always positive because it's a rectifier again. Do you understand? So we'll discuss this how in a second. And also the output voltage has also a value and slope equal to 1 here in this case again. For when Vs is above Vd, okay? There is a zone in between minus Vd and plus Vd. We'll explain that in this example next. When the output voltage is equal to 0. But it's never in this area. It's never in the negative. It's always in the positive. The input can be anywhere, negative or positive. You understand? So let's see how does it work. Let's take first example. Okay, good. We have already explained that, so again, throw it away. Thank you very much. Let's now analyze it. The center taped transformer is a special transformer, okay? Is a special transformer in the sense that this is an input voltage coming, say, from here. It's an AC signal. It's a special transformer, what you see here. This is the symbol of the transformer. Have you used transformer before? In the power electronics? No.
Yes.
ولا حتى في electromagnetics?
Circuit 2.
Circuit 2. مين أخذ circuit 2? Who took circuit 2? So transformers, you must know transformers. Yes or no?
بس دكتور circuit 2 حق الالكتريكال مو بالكوميونيكيشن.
والله هذا مش مشكلة حتى transformer you can study it. Or communication you didn't study transformers? No. But don't worry, we are not going deep anyways. Transformer is just to take a voltage from one side, give it another side. Can make it bigger, can make it smaller. That's it. Finish transformer. How is that? خلاص? How we do it? We use Maxwell equation and we are not going to spend time there. خلاص? Good? What's special about this center taped transformer is that he gives me two voltages. Okay? So this voltage, if this voltage is positive, this voltage is negative, and here, okay? And if this voltage is negative, this voltage is going to be positive. Why? Because they share a common ground, that's why we call it center taped. This is common ground between the two voltages. Huh? And that's it. So this is that transformer. It's a special. Cost a little bit more. Do you understand?
Yes.
Good. Now, when we have a positive voltage here, the diode that is here will see a positive voltage and will conduct when that voltage is above 0.7 volt. Yes or no? Yes. And when that voltage, which is in this case this guy, is above 0.7, the current will go this way. Does it go this way? No, this one is negative voltage. So this diode becomes what? Open circuit. Reverse bias. Yes or no?
Yes.
Reverse bias, open circuit. It's open. Yes or no? So the current will not go here. It will go here. To the transformer back. Okay? So the current cross R goes from up to down. So the voltage is really positive in this case.
دكتور إذا كان أصغر من 0.7.
In that case, this one also will be open and there's no current. No here, no there. So we are where? That's a good question. We are in this region you are talking about. Do you understand?
Yes.
When we are above, we are here. So in that case, do you understand? Here we can write V out is equal to what? V out is equal to Vs minus Vd. Yes or no? D here 0.7. Do you understand? Why? Go back to the circuit. Ooh. So this voltage plus this voltage will give us Vs. صح ولا لا? Do you understand? Now, this is for the positive phase. Now when it is negative phase, that means this guy is now negative and this voltage is positive. Then hello, this is going to be off, yes or no? Yes. And this one will conduct if the voltage across it is above 0.7 but in the negative side. Do you understand? In the negative side. So now we are below minus 0.7 in the negative side. More negative than 0.7. So this guy will start to conduct and then the current will go like what? And then I come here. There's no dot here like this. That means there's no relation between this wire and this wire. So okay, let's go. And now here, do I go left or right? Because it's open, yes or no? So I continue. Yes. خلاص, finish. Now the current is the same as previous. صح ولا لا?
Yes. What negative?
What's that?
Negative.
Yeah, the voltage is negative. It doesn't matter بالنسبة لنا. But the output voltage is positive or negative? Positive because the current is on the same direction. It didn't change. صح ولا لا? Does it change?
No.
You can look at the video later and you will see that we did not cheat. It was on the same direction. صح ولا لا? So, yes, as you can see, previously the current was going this way and now The same. We did as you see, had the picture change and the graph stays there. Very good, thank you very much. Now, what is the most important operation? What is the most important observation that we found here? Again, that the current at the output stays in the same direction. So that means the AC goes up and down, but here the current is always one direction. Yes or no?
Yes. But doctor, which one is the best? Full wave or?
We'll get to that. Let's finish, and then we'll talk about that.
Okay.
But apparently, I need the voltage all the time. صح ولا لا? In a small answer. So which one give me most of the time voltage?
Full wave.
Full wave.
That's it. Yani, this is the short answer. Okay, and that's good enough actually. So the full wave, about this circuit, we found that the current is always on one direction. Okay, for both halves of the AC wave, AC wave up and down, but the output is always in the up. Good. So it's more energetic, like Mahal noticed. You have always a voltage at the output. It's not there's a voltage and then there's a voltage and you sleep. No, it's always giving me a voltage. Now, the PIV of the center tape rectifier is equal to 2 Vs minus Vd. Can somebody tell me how we found the PIV equal to 2 Vs minus Vd? So what does it mean? Wait. Back. Okay. Where are you going? Come back. We are here. All right. The PIV is what? If we take this, the PIV is the same for the positive full wave or the negative full wave. Here, the PIV, it means this diode, it's a reverse bias. That means this voltage is higher than this, and the maximum value of that reverse bias, we call it the PIV, the peak inverse voltage, is equal to 2 Vs, Vs which is the peak voltage, because Vs sine, yes or no, sine something, okay, is equal to Vs, this Vs, صح ولا لا? You understand? So Vs is the amplitude, so is equal to 2 Vs minus Vd. That's the maximum voltage across this diode. This is the third bonus. If you find how we get this, you write it in a nice way to convince me. Of course, in the textbook it's written. You have to show me whether you understand or not. The bonus is not finished yet. So this is A. Remember, this is question A in the bonus.
Doctor, can you please repeat?
I repeat. The PIV of the center taped rectifier is equal to 2 Vs minus Vd. I explain here. The PIV is the maximum reverse voltage of this diode or this diode. They will be the same. Show me that they will be the same and that the PIV, that maximum voltage reverse bias, is equal to 2 Vs minus Vd. Vd is the 0.7 volt. Okay? Is the voltage drop of the diode.
So doctor, we have to verify how we...
Yeah, how to find that. Show me how we find this value. Some explanation in the textbook, don't worry. You have to show me really in different way. So no plagiarism. So I give you the source ahead of time, you see? Do not copy and paste. Write it, explain it. Because even in the textbook, he did not explain it very well. Okay, so I will understand. And the deadline is tonight, midnight. It's not tomorrow. It's tonight, before midnight. So before you go to bed, if you are interested in the bonus, have a look and send me your answer. And this is question number 1. Question number 2 is coming after this bird. Bye. So now the second circuit is called the bridge rectifier. In the bridge rectifier, we replace the center tape transformer with regular transformer. This is regular, يعني it's not cheap, it's not expensive. يعني any transformer, even a plug like this, will do the job, okay? So it's just an AC voltage, يعني هذه if I replace it with an AC source like this, boom boom, I'm fine, it's okay, it's the same story. So it's not about this, it's about this. In the bridge rectifier we have now, instead of 2 diodes, we have 4 diodes. And they are like this. Up, down, down, up. And in between them, there's a resistor. Why I did that? To make it easy for remembering. Because I know some of you will think about electrical engineering as memorization. Like this, sometimes. Okay? Good. So, so how does it work? This is the, where's the bridge? Bridge يعني إيش? Bridge يعني? In Arabic is? Jisr. Where is that? This is the jisr. See? And then it's like this is one river, this is another one, or something like that. And between them there is a bridge. Okay? Good. It's just a way of speaking. And then it flies again. To the left. Thank you. So now let's analyze this. In the positive cycle of the input voltage, this is higher, this is lower. So this guy, so initially there is no current, huh? So this high voltage comes here, okay, and then look around. So this is, you know, this is ground, and this is, so this is what? This is what? Yeah, in this case, open, صح, and this one is?
Short.
Is forward, صح ولا لا? So the current will come this way, yes or no?
Yes.
Very good. And it will come here, and then we look at here. So this one is negative, and this one is 0. I will go with that one, okay, okay. But this one is even, what makes it even worse, that this one is a diode, this is reverse bias, yes or no?
Yes.
Then this one is open, so I have to go this way. There's no chance. Then I come here I find the ground, I can escape, but here I find the negative. So I prefer to go to the negative side. But this one, and I can, because the diode here in this case is also forward bias, yes or no? Because this voltage is higher than this negative. صح ولا لا?
Yes.
So I continue and stop, close the loop. So the loop starts from here, goes there, and then finish the job. Back to the source. Okay? Now this is the positive cycle. The negative cycle is the other way. Okay? Off you go. Now this is higher than this one. So now we have this voltage comes here. This now diode was like what? Was like this, yes or no? So now it's reverse bias, then this is ground, this is higher voltage, comes here, then bye-bye. I go this way, and I look at this is negative, and this is positive voltage. So this one is like what? It's like this, yes or no? So now this is also off, so I tell it goodbye, go through the resistor, and I come here. I can go to the ground, or I can go to the negative pole, yes or no? I prefer to go to more negative. And the diode in this case, wait a second. Wait. No. I'm a bit, I need some coffee. So when here and then here, no, this already passed. So here, now I come here. This is ground, this is negative. So now I prefer to not go to the ground. I prefer to go to the negative. And this diode actually works because it's forward. So I go here and continue like that. So now my loop goes like that, goes like that, goes like that. So comparing this, the positive cycle to the negative, to the positive cycle to the the negative cycle, the current was always going on one direction. Again, rectification. My output, which I'm taking across this resistor, is always positive. Because the current going this way, that means this voltage is bigger than this. Okay, good. So again, AC goes up and down, the output voltage is always positive. Go up and down, but in the positive, yes? Yes. You have to understand that. We're not done yet. But we are here in these slides, we are trying to understand how it works. If we don't know how it works, then bye-bye. There's no point. We are trying to understand, not to memorize. Again, flying birds. By the way, do you know what that kind of birds called? Origami is Japanese, game like that. They are crazy, these Japanese. What's the main advantage of the bridge rectifier? What's the main advantage? Who knows? What's the main advantage? We don't have center taped, yes or no? Do we have center taped? we don't have special transformer. صح ولا لا? We don't have. It's the regular transformer. صح ولا لا? And we are good. Now, what's the main disadvantage? It has two disadvantages. We use now 4 diodes instead of 2,
Yes.
like the previous one. And we lose also 2 VDs, because remember, in the current, it passed by 2 diodes.
Yes.
So it loses 2 VDs, yes or no? So the output will be less than the input by 2 VDs, yani 2.7 times 0.7, yani 1.4 volt we are losing because of these 2 diodes. صح ولا لا? Got it? Excellent. Now, that's the second question of the bonus. What is the PIV of the bridge rectifier? I give it to you. It's Vs minus Vd. Yani that's the maximum voltage that any of those diodes will find in the reverse bias. Do you understand? That's the maximum. Show me how. Until midnight. خلاص? After midnight, good night. All right, and that's it for today. Inshallah, that's the end of today's class. And next class, inshallah, we'll do the quiz.